Recently I had a discussion with one of my friends around yield keyword and generators, and I decided to tackle a little bit this subject. So the entry point is the difference between coroutines and subroutines. A coroutine is a simple plain function that might do some computation. In our case, let's print a couple of strings, first and second. And in order to give the control to our caller, we're going to use the return keyword, which in our case will return another string, namely the done string. Now, one important thing, we used an explicit return. In other words, if we didn't specify what we return from our function, by default in Python we're going to return none. Now let's call our function, save the return value under a variable, and let's print a. And if we are going to run lines 5 through 15, not Porter, Python, sorry, 14, we're going to see that our function has been called. We have the first and second string, and of course under a we have the third string, which is done. But what happens if we'd like to maybe have a different behavior and give the control to our caller temporary and also maintain the state between calls? And here we have subroutines, and we're going to use the same approach, meaning we're going to have 3 strings, but instead of return we're going to use the yield keyword, and we're going to have first and second and done. Now, the yield keyword actually returns another object, which is called a generator, but we're going to see it right now. So if we call instead of our coroutine the subroutine, we're going to have lines 5 through 19. We're going to have a generator object, and a generator object, it's basically an iterator, but it has a couple of interesting things, one of which this next method that allows us to extract one value from our function. So in our case we're going to have the first value, the first string. If we would like to have the next value, we're going to call next once more, and we're going to have first and second, and last but not least, if we would like to have the third value, we're going to call next. So actually this is a little bit of syntactic sugar, because behind the scenes the next dunder method is being called. So if we call 3 times next, we're going to have each value yielded from our subroutine. And one interesting thing, if we decide to go further, we're going to encounter a stop iteration. But this begs the question, okay, how our subroutine knew to return this stop iteration? And for this we're going to implement our own generator. So we said that the yield keyword actually returns a generator, and let's create a simple object, we're going to decide that our generator is called repeater, and we need to implement 3 methods. Of course, init dunder method, And let's start shaping the behavior of our repeater. It's going to receive a name and the number of iterations. So we said that we have a name. We're going to do the same thing for the number of iterations. And we're going to start to embed our logic in here. We're going to have a counter which will initialize to 0. And we're going to have another method, the iter one, which actually returns the iterator. So this is pretty straightforward. And last but not least, we're going to implement the next method. And here we're going to start to embed our logic. First and foremost, we're going to increment our counter, and we're going to have a condition that dictates the behavior of our iterator, of our generator more exactly. So if self.counter, so if our counter is smaller than number of iterations, then it's safe to maybe return the name of our object. Otherwise, we're going to raise a stop iteration. Now, if we are going to create a instance of our generator, let's call it R. So we decided that it is called a repeater, and we need to pass a name. Let's call it test, and the number of iterations. And we decide to have a maximum of 4 iterations for our object. So if someone decides to iterate to our object, and let's do this. So lines 3 to 23, we can see that the name of our object was printed 3 times. If we would like to force a little bit of things, we can use the same approach as previously, meaning call next on our object. So lines 3 to 21, we can see that we successfully returned the name of our object. But guess what? If we abuse this and try to surpass the number of iterations, the number of maximum iterations, we can see that we have a stop iteration. So in simple terms, these are the biggest differences between subroutines and coroutines, and this is a generator object, which basically at the core of it's an iterator implementation.